F applied in a way as shown. We have masses m3, m2, and m1, and on the application of force, the system moves as a whole with common acceleration. Now, let's see for mass m3. Okay, if we analyze the forces acting on the mass m3, we see, okay, let's produce this horizontally this way. Now this force is applied like this. Okay, let's draw it from here. Let's draw it from here. Now this angle is theta. Now the component in this side is F cos theta, and the component in this side is F sine theta. The weight m3g acts vertically downward and the normal reaction acts upward. Here is the mass m3, m3. Okay. This m2 exerts normal force n2 on m3. In the same way, this m3 exerts normal force n2 on m2 as well. Now, let's write those forces. Okay, F cos theta and F sin theta are the rectangular components as shown. Weight m3g acts vertically downward, and 2 is the normal force exerted by m2 on m1. R3 is the normal reaction. Okay, now the forces along the x-axis are F cos theta and n2. F cos theta and n2 are in opposite direction. Now apply Newton's law. F cos theta minus n2 equals to m3a, and along y direction the forces are r3, f sine theta and m3g. F sine theta and m3g are in one direction and r3 is in another direction. That's why again from Newton's law we get r3 equals to f sine theta plus m3g. Okay, now let's do same for mass m2. The weight acts vertically downward. The normal reaction acts upward. Now, here we have mass m2. We have mass here m2. Here mass m3. Sorry, m1. As we discussed earlier, n2 is the normal force exerted by m2 on m1. Similarly, m1 also exerts normal force n2 on m2 n2. Okay, for m2, this mass m1 exerts normal force, let's say it n1. Similarly, this mass m2 also exerts normal force n1 on m1 as well. Let's include those forces also, n1. Again, now let's use Newton's law. N2 minus N1 equals to M2A along x-axis, and along y-axis R2 equals to M2G. Now it's turn for M1. Okay, N1 acts on M1 too. N1, as we discussed earlier, the weight acts downward. This is the normal reaction. Now these are only the forces acting on M1. Now along x-axis we see there is only one force, N1 equals to M1A. A is the common acceleration, and along y-axis R1 equals to M1G. Okay, now the horizontal force acting on the system is F cos theta, and the total mass is M1 plus M2 plus M3. M is the total mass and the horizontal force is F cos theta. Now apply Newton's law of motion. F equals to ma. That's why A becomes F horizontal net upon M total. For mass M1, N1 equals to M1A, and we substitute the value of A to get the value of N1. Now for mass M2, N2 minus N1 equals to M2A, N2 equals to N1 plus M2A. Now substitute the values of N1 and A in order to get N2 from previous values. Please follow our page Physics with Physics for more videos and updates. Thank you.